Good morning, students. Myself, Vijay Shankar from ECE Department, Chepal Engineering College. Today, I am going to discuss about some more examples in the electrostatics. That is the third unit. So, we already completed some examples. Now, let us see the examples on the conductor or current density and related to the current. In a cylindrical coordinates, J bar is equal to cylindrical coordinate J bar is equal to 10 into e power minus 100 R K5 bar ampere per meter square. Find the current crossing through the region. Find the current crossing through the region in the range of 0.01 to the 0.02 meters. And Z is 0 to 1. An intersection of this region with the phi is a constant plane. Okay, the current is given by the integral form of continuity equation as I is equal to integral J bar dot ds bar. I is equal to integral J bar dot ds bar. Since the given function J is in the a phi direction, J is equal to the given 100 into e power minus 100 R a phi bar. So you can take the ds also in the a phi bar direction. So differential surface area normal to the phi direction. And because it is a cylindrical coordinate system, dr r into d phi and the dz. So along the phi direction means there is no component of d phi, and we have a dr and dz. So dr dz a phi bar. So substitute in the j bar dot ds bar as a phi bar dot a phi bar is equal to 1, and it becomes of 100 into with the integral of r is there. R is ranges from 0.01 to the 0.02. R is equal to 0.01 with the range of 0.02 e power minus 100 into R dr, and the z is varies from the 0 to 1 dz. Okay, apply here the integral for the exponential e power minus 100 into R by minus 100 with upper limit is 0.02, 0.01, and the z with the upper limit is 1 and the 0, that is equal to, so 100 here the 100 is there, minus term e power minus 100 by the 0.02 means e power 2 minus 0.01 e power minus 1, the z is a 1. Okay, now it becomes of e power minus 1, minus into minus is a plus, and minus e power minus 2 is a value. Okay, so actually it is a 10. I wrote here the 100, and here the 10 is the denominator. It's only the 10 tenths. So 10 by the 10. Let's simplify this function. E power minus 1 minus e power minus 2 by the 10, we get the 2.32 into 6, 10 power minus 2 amperes, because it is a current is equal to. Okay, because the current is equal to. Here the 10 is there, take the common of 100 here. By 100 you can take as a minus value, 10 tenths. So 1 minus you can multiply here, e power minus into minus e power minus 1, and minus e power minus 2 by the 10 value. To simplify the function, and we'll get the 2.326 into the power of minus 2. So find the current crossing through the region of R and the Z, and the intersection of this region with the phi as a constant plane. Word my distance. The next one. So find the total current in outward direction from a cube of 1 meter. Find the total current in outward direction from a cube of 1 meter with one corner at the origin, and edges parallel to the coordinate axis if j is equal to 2x square ax bar, 2xy cube ay bar, and 2xy az bar. Is a plus minus, students. Inside it is a ay bar, and here it is a plus is also. J is given. Find the total current. What is the total current here? The I is equal to integral j bar dot d to the Ampere circuit law, or it is a continuity equation that's saying. And converting the surface integral to the volume integral, whatever the term is there here, to apply the del dot g bar into d. So already we know the d bar dot ds bar is equal to rho v, the Maxwell's equation. Same way, the del dot d bar into d. Instead of d here, the j is there, j bar dot ds bar. The cube of the volume, hence the volume is a volume of it when you consider it as a Cartesian coordinate system, is a small differential x, differential y, and the differential z, dz. Not here, this is a dz. Okay. So all the three terms, the volume is there, the dv is equal to dx, dy, and dz. Del dot g bar is equal to del dot j bar is equal to dou by dou x of jx, dou by of gy, and dou by dou z of dou z, jz, not the dou z. What is a jx here? Ax bar coefficient is a jx. And so j bar is equal to jx into ax bar plus jy into ay bar plus jz into az bar. Got it? Jx term is given in the input function 2x square as a jx, and jy is given as a 2xy cube, and jz is equal to 2x1. But is a coefficients of ax, ay, and the az. Apply here the dou by dou z of dou x of 2x square, dou by dou y of 2xy cube, and dou by dou z of 2xy. So in the first equation, it is with respect to the x. So 4x will get 2 already there, x square derivative is at 2x, 4x will get 2x is the constant, and y cube is nothing but 3y square. 3y square means 3 to 6, 6x y square, and there is no any z constant of that is a 0. So 4x plus here, and the dv is with respect to x, with respect to y and the z. So integral I is equal to the volume integral 4x plus 6xy square dv. dv is nothing but, okay, that is equal to, what is the x here with respect to the value, the cube considered as a 1 meter, means origin to the 1 here, and origin to the 1, and origin to the 1. All the sides is the same in the cube. So x is equal to 0 to 1. First of all, we can apply here that 4x plus 6xy square means 4x, the integral 4x plus 6x y square. First of all, with respect to the x, 4 plus 6y square. 4 plus 6y square. There is no any 6, and apply the dy here. 4 is a constant, is a 0, plus see the 2. Again, you'll get apply the first of all here. We can take that is a 4x square. I'm applying here. It's a derivative, not the integral minus squares. 4x integral is a 4x square by 2 and 6x square y square by 2. Apply the 0 and 1. Another integral is there, the dy and the dz. So after substituting the 1 here, 2 plus 6y square. 2 plus 6, not the 6, here the 2 is there. With respect to the 2, and here also the 2. 2, 6 y square, it is a 6 by 2, that is a 3y square. And again, it is a d. You can take the y is equal to 0 to 1. 2y plus 3 equal to 3. So 3 into z. Again, it is a 0 to 1. Yes. Okay. I is equal to 3 amp. Next example. The current is 1 AR bar. Ampere per meter square in the spherical coordinate system. How much current flows to the spherical cap R is equal to capacitance is for the R is equal to 3. Zero to pi by 6 and phi is equal to 0 to 2 pi. The spherical coordinates is a J bar. We need to find the current I is equal to bar dot. J bar is in terms of ds bar is also you can take as a spherical coordinates system. R sin theta d theta so ds r bar is equal to r into d theta r sin theta, sorry, here. Okay, now substitute that in the integral I is equal to integral R is given 100 into R d theta R and A R bar dot A R bar is equal to 1. A R bar. So now the theta value is there and the phi respect to that is equal to, there is no any R terms. So 100 R square, I think, by R square plus 1 is a constant. And cos theta, sin theta, integral d theta, and another integral d phi. Okay. Now the cos theta and the sin theta is the theta is varies from the 0 to pi, and the theta is from the 0 to pi by 6 they given. Okay, pi by 6. Theta is equal to pi by 6, 0 to pi by 6, and the phi is varies from the 0 to 2 pi. Okay, so 100 r square by r square plus 1 is a constant, and again multiply and divide with the 2 here. It becomes of 2 cos theta sin theta is nothing but a sine. So finally the expression becomes of 100 r square by the 2 into r square plus becomes of sine 2 theta with integral of theta is equal to 0 to pi by 6 pi only. Then you have 2 pi after substituting, and sine 2 theta is integral is 100 r square after getting the cancel of 2 here, 100 r square pi by r square plus 1 as cos 2 theta, and the theta coefficient is a 2. The upper limit is a pi by 6 and the lower limit is a 0. So the minus 250 is here, minus 50 pi r square whole divided by r square plus 1 minus already there. So cos pi by 3 minus cos 0 is a 1. Okay. And now we can simplify after substituting the r as 3 squares and 9. See what here is at 10. We're substituting r is equal to 3 here and find the value of cos pi by 3, and then finally we'll get 70.6 amperes. Now it is r is equal to 3 we find, when r is equal to 10 meters, r is equal to 10 meters. The second one, the coordinates r is equal to 10 meters, and theta is varies from the 0 to infinite, and the phi is varies from the 0 to 2 pi. Nothing is changed here, only the 0 to infinite for the cos 2 theta by 2. Cos infinite minus cos the infinite value here. They're asking that the alpha value. Okay, what should be the value of alpha? Okay, cos alpha I can take here. Here, not the infinite, it is alpha value. So simplify the function of the substituting r is equal to 10 when the current is 858 and the phi integral d phi is a phi, and integral of sine 2 theta is a minus cos 2 theta by 2. Substitute the upper limit and the lower limit alpha and the 0 in terms of the degrees 28.47, and in terms of the radians the next example. Of 7 ohms per meter has 10 power 29 free electrons per meter cube. The given it is a wire of diameter 2 mm and the conductivity 5 into 10 power of 7 ohms per meter has 10 power 29 free electrons per meter cube. It is subjected to an electric field of 10 millivolts per meter. Determine determine the free electron charge density. Free electron charge density, my dear friends, rho E, and the current density J. The current in the wire, nothing but you can find out the I, and also the drift velocity of electrons, Vd. Okay. So what is given here? The wire of diameter 2 mm. The diameter and the radius is nothing but here we know pi r square means r is equal to, you can write as in terms of diameter is d by 2 whole square. It becomes pi d square by 4. The r is given, and also the conductivity is given. Conductivity means sigma. Sigma is given, that is 5 into 10 power of 7 moles per meter, and has a free electrons per meter is a 10 power 29. So actually 1 electron is minus 1.6 into 10 power of minus 19 coulombs. But as asking for as 10 power 29 free electrons per meter cube. It is subject to the electric field also. Given the electric field, E is equal. What is the E? 10 milli, 10 into 10 power of minus 3 volts per meter given. Okay. So now what is the N is equal to? Given it is a 10 power 29 free electrons per meter cube, and 1 electron is equal to 10.6 into 10 power of minus 19 coulombs. Therefore, the rho E is equal to the first one is the free electrons charge density. Rho E is equal to N into E. The given it is a N. E is 1 electron is equal to minus 1.6 into the power of minus 19 coulombs. So free electron charge is equal to 10 into the power of 10 power 29 into minus 1.6 into the power of minus 19. We'll get as a minus 1.6 into 10 power of 29 minus 10 is, we'll get the positive value of 10 power coulomb per meter. And second one, they're asking that is a current density. The current density relation between of electric field and the conductivity, rho E bar, J bar is equal to, actually the J is equal to sigma into E. What is the sigma given? 5 into 10 to the power of 7, 5 into 10 to the power of 7. And electric field is also given the 10 into 10 power minus 3 in terms of the milli. So the J, we got the current density is 500 kilo ampere per meter square. 500 kilo ampere per meter square. And the third one, they're asking the current also, the current in the wire. The current in the wire, that wire is given as a 2 millimeters. Okay, that is a current, we know the J into S. What is the current? I is equal to, if it is in the dot product, J bar dot ds bar. The last example we did, J bar dot ds bar. If it is in the normal magnitude, J bar is a J into AN bar, ds bar, ds into AN bar dot AN bar, it becomes of one value, and we have the I is equal to the magnitudes, only the magnitude J into S. What is the S? The surface area. The pi d square by 4. J, what is the J? We got the 500 into K. So 500 kilo, 500 to the power of 3, pi by 4. The D is given the 2 milli. 2 milli means 2 into 10 to the power of minus 3 whole square. You can simplify this one, you'll get the 1.577 amperes because it's a current. And also, the J is related, the current density is related, the free electrons charge and the drift velocity. We need the drift velocity, Vd is equal. We got the J as 500 kilo ampere per meter square, and rho E. We need the Vd is equal to, J is equal to, is I think it is a Vd, we have to find out the J we got, that is equal to rho E. What is the rho E? We got 1.6 minus students. It is 1.6 minus 10 power 10 into VD. So VD is equal to 500 by, here the square is there, and power 3, 10 power 5, and here the 10 power 10. You need to have only the 10 power 5 in the denominator, and 5 by 1.6, the minus 3.12 into 10 to the power of minus 5 meter per second. Okay, the negative sign indicates that it is positive to the direction of applied electric field. The drift velocity is the positive, opposite to the direction of the, or the positive, sorry, it is opposite to the direction of the applied electric field E bar. Got it, my students? Here there is so many formulas we used to find the free electron charge density. Rho E is equal to N into E, and N is given the 10 power 29 free electrons per meter cube. Actually, one electron, the charge of one electron is equal to minus 1.6 into the power of minus 90. Multiply the two, you'll get the free electron charge density. And the current density, sigma into E, and current is equal to J into S, and J is equal to rho E into VD. Rho E into VD. Okay. The velocity, drift velocity into the free electron charge density is nothing but the current density. Okay. Coming to the next example. An aluminum conductor is 2000 feet long and has a circular cross section with a diameter 20 millimeters. Aluminum conductor is a 2000 feet long, means it is a given, it is a length. Okay. As a circular cross section, the diameter is also given. L is equal to, so given is L is equal to 200 feet, not the 2000 feet long, and having the diameter D is equal to 20 milli power minus 3. If there is a DC voltage V is equal to given 1.2 volts between the ends. Find the current density. Find the current density means J is equal. What is a J? The current I is equal to, and the power dissipation from the knowledge of circuit theory as conductivity is given. They are asking that is a P also. P is equal to, in terms of the sigma is equal to given, that sigma, the conductivity 3.82 into 10 to the power of 7 ohms per meter. So these are data given. How to find out the current density and the current and the power. The power P is equal to. Okay. Using these relations, the J is equal to V, L, and the D is given, means E is equal to the formula we already have. The voltage is applied to the conductor with the length of the conductor is L. The electric field E is equal to applied voltage by the length of the conductor, V by the L. What is a V? 1.2 volts. And the length in terms of the feet is given, but it is converted to meters. Feet is a 200, and the meters means 30 into 10 to the power of minus 2 meters. Converting into the meters, 30 into 10 to the power of minus 2. Okay. 1 feet is a 30 centimeters minus 2. 1 feet is equal to 30 centimeters. All right. So, in terms of the meter, it is a 10 power minus 2. So, 30 as in terms of the centimeters. If it is a meters, 10 power minus 2. So, L is equal to 2000 feet is in the 600 meters. Okay. So, 600 you can write here. And 12 by the 6000. And 12 we can remove that. We can get it is a 2 into 10 power of minus 3. 6 2s Okay, 1.2 means 12 by 6,000. So 1,000, we can write it in the numerator as 6 2 into 10 to the power of minus 3 volts per meter. Volts per meter. Electric field is nothing. The J is equal to, what is the J here? The current density. The current density related to the electric field is J is equal to sigma into E bar. What is the sigma given? 3.82. 3.82 into 10 to the power of 7 multiplying with electric field. That is a 2 into 10 to the power of minus 3. 2 into 10 to the power of minus 3. Sigma is given the 3.82 and 10 power 7 and 10 power minus 4 into 2 here you can write 10 power 7 minus 10 power minus 3 is 10 power 4. Got it, my student? Simplify this function and we'll get it is a 76.4 kilo ampere per meter square. Kilo ampere per meter square. Got it, my students? Then also you can find that the current is equal to, what is the current in terms of the density, current density J and the surface J into S. Okay, what is the J we got now? The 76.4 kilo. Kilo means 10 power 3. And J is the surface area given in terms of the diameter it is here pi into R square. Nothing but the D by 2 whole square. D given the 20 into milli 10 power minus 3 by 2 whole square. Because it's actually a pi R square. To simplify this function, we get the 24 amperes. The current we got as a 24 amperes. Here also it's a very, very important examples. Example 5.4 and the 5.5 because there is so many simple formulas are there. So directly you can substitute that values and you can find the given, find the current density, current and so on. And the power also, the last one you have to find out the power. P is equal to power dissipated. P is equal to, we have the formulas in terms of the current is I square R. Or otherwise in terms of the voltage, V square by R. Okay, V square by R. That is equal to I square. I square we already got it is a 24 I and 1.2 into 24 we get again. That is a voltage in terms of the voltage, my students. The voltage is V 1.2 V into and the current V is equal to 24. The V square by I or the I square into the R or otherwise a V into I also. 3 formulas we have. V square by R or the I square by R, I square into R, sorry, and V into I. The voltage into the current. The voltage we got it is a 1.2 and the current is a 24, totally 28.802 watts. So here also in this example also we have the formula. So E is equal to V by L and J is equal to sigma into electric field E. The previous example also we got, and I is equal to J into S. This also will get in the previous example. And the power is equal to V into I, the V square by R or I square R. And the V we got to have 1.2 and the current is a 24. So power is equal to 28.802. Got it, my students? Okay. So coming to the next example. So determine the relaxation time for silver having the conductivity 6.17 into the power of 7 ohms per meter. If charge density rho is placed within a silver block Find the charge density after one time constant and 5 times constant. Assume epsilon is equal to epsilon. They're asking for t is equal to 1 time and t is equal to 5 times also, 5 times of the constants. Conductivity is given, sigma is equal to 6.17 10 power 7 moles per meter, and epsilon is considered as epsilon naught. That epsilon naught is equal to 8.854 into 10 to the power of minus 12. The relaxation time, my dear students, is already we did in the theoretical class. The relaxation time, that is tau is equal to epsilon by the sigma. Epsilon by sigma. It is also very important. The 5.4 example, 5.5 and the 5.6 also. Tau is equal to epsilon by the sigma. What is the epsilon? We consider this epsilon not only 8.854 into 10 to the power of minus 12 divided with given the sigma, the conductivity of the silver, 6.17 into 10 to the power of 7. It is also the meters. So simplify this function. 10 power minus 7 will get in the numerator. 10 power minus 12 and minus 7 is 10 power minus 19. And these two will get is a 1.43. The tau is nothing but the time, relaxation time in terms of the seconds. The tau we got 1.435 into the power of minus 19, sorry here, 19 seconds. And the charge density decays exponentially. They are asked to find the charge density given as a charge density rho naught at initial value. Rho is equal to rho naught into e power minus t by tau. Okay. At the t is equal to 1 tau constants, so 1 time constant. Find the charge density after 1 time constant. Rho naught into e power minus t is 1 tau. And we got the tau is 1 point. It is also the tau. We can write as a tau only. Get cancelled. And the rho naught into e power minus 1. E power minus 1, the value is a 0.3768. Similarly, at the 5 tau, the rho is equal to nothing but is a charge density. Rho naught into e power minus 5t is nothing but is a t is a 5 tau. 5 tau. So tau get cancelled. E power minus 5 is 6.73 to the power of minus 3. 6.73 into 10 to the power of minus 3 and the rho naught. Got it, my students? It's a very, very important. So many formulas are related. These three, the last 3 examples, 5.4, 5.5, and 5.6. Got it, my students?